let's do some more practice on VSEPR. So this is going to be when we have 5 or 6 electron domains. Now, interesting connection with this, 5 or 6 electron domains. 5 electron domains means that you have 10 electrons around the central atom, 12 electrons around the central atom if it has 6 electron domains. So everything you see on the board, these are all expanded octets. A little disclaimer, not sure that all of these compounds really exist, but they'll show you what you need to know for VSEPR. So let's just jump in and do the practice. We've got I3 minus. So we look at the central atom, count electron domains. Iodine central atom has 1, 2, 3, 4, 5. Let's do that again. 1, 2, 3, 4, 5 electron domains. So 5 electron domains, the electron geometry is going to be Trigonal Bipyramidal. And these you just have to memorize. Watch my video that introduces, it's part 1 and part 2 of VSEPR, to help you look at the shape, visualize it, and make sense of these words. It's like 2 pyramids on top of each other. Trigonal, oops, sorry, I forgot the word bi-pyramidal, talking too much. Okay, now what would be seen? You can't see those 3 electron domains in the middle. So imagine the iodine in the middle, and you've got 1, 2, 3. It would be like a triangle of electron domains, and then you have your iodine on the top, iodine on the bottom. All that could be seen would be this straight line. That is linear. So the molecular geometry is linear. Now let's look at angles. The angle that would be seen is 180 degrees. 180 degrees. But there are really 2 other angles on this. So the molecular geometry was seen 180 degrees, but you'll recall that triangle in the center, between here, between these lone pairs, that is 120 degrees, a triangle, not a big deal. And then going from this atom to the lone pair, that is a right angle. So from here, from this bond to that is 90 degrees. That's 90 degrees. And again, watch the introduction to VSEPR. Electron domains is part 2, electron domains 5 and 6, and that will help you visualize this. Or memorize 90 degree, 120 degree, 180 degree on trigonal bipyramidal. Okay, now we're going to have the iodine tetrachloride. So count electron domains around the central atom. 1, 2, 3, 4, 5, 6. We've got 4 bonds, 2 lone pairs. So 6 electron domains. I'll come back to it, sorry. The electron geometry is going to be octahedral. Octahedral. Now what's seen? Okay, picture this. You've got iodine in the middle. Those chlorines sit on one plane in a square. You've got chlorine, 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 chlorine. So 4 chlorines, like a square, on one plane, and then you have a lone pair and a lone pair. So the molecular geometry on this is square planar. Square planar. Now, the great thing about octahedral is you have all these 90-degree angles. So if you have the iodine in the center with a square, well, between all of these chlorines is 90 degrees. From the lone pair to this chlorine, that's also 90 degrees. You do also have the 180 from the lone pair to the lone pair. So from here to here, that would be your 90 degrees. From the lone pair to there, that's 90 degrees. And then from lone pair to lone pair, that's 180 degrees. So you're going to put down 90 degrees for what's seen, 90 degrees. I forgot to put on hybridization. Okay, so hybridization, S has a maximum of 1 exponent, P is 3, D is 2. And we have to have the exponents add up to the number of electron domains. So over here on the I3 minus, we had 5 electron domains, so the hybridization would be S, P3, 1 plus 3 is 4, D plus 1 is 5. Now there's debate right now about that D hybridization. If you're in AP, they've taken out this D. They won't ask you hybridization for electron domains 5 and 6. In case your professor is still using that, that's how you figure it out. Okay, 6 electron domains. Here we go. Hybridization would be sp3d2. 1 plus 3 is 4 plus 2 is 6. So there would be your hybridization. Okay, we've got a chlorine tribromide. So count electron domains. 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5. There we go. So we've got 3 bonds and 2 lone pairs, 5 electron domains. 5 electron domains, the electron geometry is going to be Trigonal Bi-Pyramidal. Now on this, what you see, okay, so you've got chlorine in the center, and we're going to have the bromines, 1, 2, 3. So they look like a triangle right here. A lone pair on top and a lone pair on the bottom. This is one of the silly names. This is called T-shaped, as if you connected that line and went straight down. I know, just memorize it. I'm sorry that's what scientists chose. Every once in a while, I have to apologize to students. T-shaped, T-shaped. Now, angles on this, so it's going to follow suit here. You're going to have 120 degrees because that's in a triangle shape. You'll have from top to bottom, that is your 180 degrees. But then from the top to that middle part, that is 90 degrees. So writing down all the angles, you've got the 180, the 90, and the 120. Let's see here. Hybridization. So 5 electron domains, we've got sp3d. 1 plus 3 is 4, plus 1 is 5 electron domains. Okay, the selenium hexabromide. Let's count electron domains. 1, 2, 3, 4, 5, 6. They're all bonds. So we're going to not only have the electron geometry be octahedral, but that's also what we would see. We'd be able to see all of those, theoretically, if we could see. It's always going to be evidence that allows us to see this. Did you like air quotes there? Here we go. Electron geometry and molecular geometry is going to be octahedral. Octahedral. Remember, we can't see the lone pairs. The angle for everything, love this, 90 degrees. We've got 90 degrees. Hybridization, sp3d2. So 1 plus 3 is 4, plus 2 is 6. Now to visualize this, you've got selenium in the middle. Then you've got 4 bromines on a square plane. So 1, 2, 3, 4 bromines. You have a bromine up top, a bromine down bottom. So it looks like you have a pyramid in essence with 1, 2, 3, 4 sides, and down at the bottom, 1, 2, 3, 4 sides. So it's octahedral, 8 sides, 8 faces. Okay, let's come down here. So we've got a sulfur tetrachloride. Count electron domains. 1, 2, 3, 4, 5. 5 electron domains. So the electron geometry is going to be Trigonal Bipyramidal. Pyramidal. Now we can't see that top electron domain. So this shape, this is the worst name out of all of them. Molecular geometry is called Seesaw. Okay, it's Seesaw. Our angles on this, because of Trigonal Bipyramidal, we're going to have, let's see here. Got that? We're going to have the 120, 180, and a 90 degree. So all 3 of those angles. Let's see here. To visualize this, and I don't think I drew this super well, it might be kind of hard to see it. You've got your sulfur. You actually have 3 triangles, or 1 triangle, so 3 points on one plane. 1, 2, 3 chlorines, a chlorine down here, and you have the lone pair up top. You have the lone pair up top. So the molecular geometry is supposed to look like a seesaw and 2 people sitting on it. It's ridiculous, just memorize it. So hybridization on this is going to be sp3d. sp3d. Okay, moving on. We have our phosphorus pentabromide. Count electron domains. 1, 2, 3, 4, 5. And all 5 electron domains are bonded, which means, theoretically, we could see all of those. So the electron geometry and the molecular geometry are the same. These are both going to be Trigonal Bipyramidal. Trigonal Bipyramidal. So the triangle in the middle, that's your 120. So there's your triangle in the middle, and then you have a bromine and a bromine, sorry, top and bottom, that's your linear. That's going to be the 180. And then, so here's my triangle, with a bromine up top to this bromine on the corner, that is a right angle. That's your 90 degrees. 5 electron domains is going to be sp3d. 1 plus 3 is 4, plus 1 is going to be 5. Okay, now we have the bromine Penta iodide. Good morning. Okay, so let's count electron domains. We've got 1, 2, 3, 4, 5, 6. 6 electron domains. 1 is a bond and 5 are bonded. Or excuse me, 1 is a lone pair, 5 are bonded. So 6 electron domains. The electron geometry, the shape that all 6 electron domains creates, is octahedral. But what we see, okay, picture this with me. You've got your bromine. We've got our square of iodine, 1, 2, 3, 4 iodine. Then you have an iodine down below. The lone pair sits right up here. What we would see is a pyramid with the square base. So you have your square base and then the 4 sides. So this is called square pyramidal. The molecular geometry square pyramidal. Angles on this, love it, because we have a square and then a right angle from the atom that's on the square down to the bottom. That's your right angle. We are going to have 90 degrees, and then from this iodine to that lone pair would be 180 degrees. Let's do hybridization. 6 electron domains, sp3d2. So we've got 1 plus 3 is 4 plus 2 is 6. Wow. And we've covered, you've had practice doing at least one of every type of electron geometry and molecular geometry if you have expanded octet for 5 and 6 electron domains. Wow, what a workout. You did awesome. If you need to go back and review the basics, go back to part 1 and part 2 of the VSEPR explanation. Thank you. Have a really good day.